Right, bitmap images. How do we store an image in a computer that only understands numbers? Well, one way of doing it is by breaking up that image into identifiable locations, little squares, and saying what color is that square, and then converting that to a color and storing that. As you can see in this image, the resolution, or the number of pixels or addressable areas, is quite few. So the image looks very what's called pixelated. Each one of those pixels has a number stored behind it that represents the color that that pixel should represent. Right, a few keywords here then. Resolution, used to describe how good a video is to display an image, and it's calculated by the pixels per row multiplied by pixels per column. So you might get a video that's got 1024 by 768. That's Super VGA, that is. But most modern videos are about that, if not better resolution. We'll come on to that later on. Resolution of an image is expressed as the number of dots per inch or dots per centimeters. So it's just worth noting. DPI, dots per inch, is often how an image is expressed if you're speaking to a graphic designer. Okay then, so if we have a look here then, here is a very basic bitmap holding only 4x4 pixels. 4 times 4, oh crap, 4, 4, 16, isn't it? Yeah, 16, so 16 pixels. So each pixel needs to have a number assigned to it to determine what color that pixel is going to be. In its simplest form, it can simply be either black or white. So we could make up an image like this. So each one of these is going to be stored as black, and each one of these pixels is going to be stored as white. Very simple. So the color depth is 1 bit, because 1 bit can store either a 1 or a 0. That's fine. The tricky thing comes when you want to store true color or colors. So obviously 1 or a 0 will not suffice. You want to store the color code of, say, green or blue or red. So that then obviously means we have to have a more complicated numbering system for this. Right. As you may or may not know, a color can be defined by its red element plus its green element plus its blue element. So, I mean, I'm no expert, but if we said it was 27 for red, 30 for green, and 10 for blue, that would make a shade of purple, I should imagine. So what we want to do then is store this number. And obviously we're going to have to store 3 of them for each pixel to create colour. And depending upon how many colours we want to be able to store will determine how large a number these are going to be. Okay, what do I mean? Well, let's have a look back on the screen for a second. Oh, gone too far. There we go. Right. So you can see that with 1 bit, that's monochrome, you can only have 2 colours, black or white. But let's say, for example, we have 4 bits that define the red element, 4 bits that define the green, and 4 bits that define the blue. That makes 12 bits in total. Well, this configuration enables us to define 4,096 different types of colour per pixel. But then our image will be the number of pixels multiplied by 12 bits in size. And that's something you may need to consider when storing your image or using your image or transmitting your image. How many pixels, how many colours do you really need? Because that will determine how large your file is going to be. For example, here, if we wanted a 24-bit true colour image, we'll need to store an 8-bit number for red, 8 for green, 8 for blue. Now you multiply that together, you're going to give yourself 16 million colours, but for every single pixel in your image, you're going to have to store 24 bits. Well, let's work that out. So 8 times 8 with a colour depth of 1 will be 8 eighths, which I believe is 64. But 100 times 100 is going to be 100 multiplied by 100 multiplied by 12 bits, which, if my maths will serve me correctly, which it probably won't, is going to be 12, 1, 12, 1, 2, 1, 2. Bits. So if you want to put that into bytes, you divide that by 8, which will give you the number of bytes, and then if you divide it by 1024, that will give you the number of megabytes. .640 by 400. We're not even at VGA resolution here, but 640 by 400 multiplied by 24, that's a very, very large number. You can work that out for me. VGA is that 640 by 400 VGA? I can't remember now. Is that VGA? Let me have a look. VGA, that's right, 640 by 480 is VGA. So it's 640 pixels by 480, and then you multiply how much of a color depth you want, and that will determine how big your file size is going to be.